All right, welcome back, everyone. We're going to switch things a bit in the fact that now we're going to start with the graph of a parabola, and the task is to write the equation of such parabola. All right, but before we do that, I think we should familiarize ourselves with our parent function. So I'll give you a little challenge. See if you can label any 5 points. Try to get as creative as you can. Don't label the easiest ones for labeling 5 points for the parent function. All right, I'm going to pretend that 20 seconds passed by, so let's check our work now. The easiest one that hopefully you identify was 0, comma 0. When x is 0, we square it and get a y value of 0. 0 squared is 0. And then some of you would have said, all right, the next x value I can square it is 1. When we have 1 squared, we get a y value of 1. And my hope is that if you've been paying a lot of attention and gaining insight of what we've been doing before, you notice this is a point of symmetry. And didn't even have to calculate that. You just knew that it was negative 1 comma 1 point of symmetry. And of course, some of you are going to say, all right, yeah, I know the next one is pretty easy. I'm going to say 2. When x is 2, we get a 4. But in my opinion, that's, like I said, that's taking the easy way out. But unless you were doing symmetry, then that's pretty cool. Like if you were doing this by using symmetry and calculating this one and not worrying about this one, that's pretty cool, actually. All right. But then I'm going to get a little more fancy. Like I said, I don't want to. The next lazy one would have been 3 comma 9. And then the next lazy one would have been 4 comma 16. But if you skipped a bunch and said, all right, I'm just going to go straight to x equals 5. What's the y value? 5 squared is 25. And what is its matching point or its corresponding point of symmetry? It is negative 5. The y value matches as 25. This is more than 5, but just to give you an idea, if you know 1 point, you can use symmetry and figure out, save yourself a lot of work, which a lot of textbooks make you calculate values through a table of values, which is not necessary through this type of thinking. Anyway, let me not talk about that anymore. But there is at least more than 5 points. We succeeded in that. Okay? So let's figure out what else we can do. All right, now this says, let's write the equation of a parabola. Let's reverse it. Actually, we didn't write an equation here. It was given to us. But now only the parabola is given to us. We're expected to write something like y equals something squared. And same thing here. It looks like the parent function, but let's ask ourselves, is this equation, this parabola, the same as this parabola? What is the vertex? It is 0, 0. Do they share any other points in common? They share that one in common. They share that one in common. Anything else? We don't know because it was not given. Oh, but look, what is in common about this 2 comma 4 and this 2 comma 4? These two are in common. So therefore, this must be y equals, remember that it's an implied 1, a equals 1, just to not show any work. We want to make this video the shorter that it has to be. So y equals 1x squared, but I like to write it as y equals x squared. And how do we know that? Because those 2 points are the same. That's it. All right, then let's analyze the next one. Do they have any common points that they share? Yes. 0, 0. So again, and I didn't write it, but it's got to be some form of y equals ax squared. In this case, it was that a equals 1. We saw that here. So we got to think the same. It's got to be some form of y equals ax squared. Now I'm going to ask myself, is this parabola the same as this one? It's not drawn to scale. The 0, 0 is the same as this 0, 0. But the other 2 points, are they the same or are they different? What is the same? Look, this x value of 2 is the same as this value of 2. So far, they look the same. But what about the y value? This is a y value of 4. This is a y value of 12. Something more has been going on then. This a's got to be more involved in this case. So let's get that into the equation. What does the 2 represent, an x or a y value? What does the 12 represent, an x or a y value? The x is a 2. Therefore, the y must be a 12. And now we can make some substitutions. Anywhere we see a y, we can substitute a 12. So this y can now be replaced with a 12. And then we know that the x term The a term, the vertical scale is what we're looking for, but the x is 2. So now we can say times 2 squared. And what is 2 squared? It is 4. And what is 4 times a? It is 4a. So on the right side, we can simplify that to 4a. The left side didn't change. We keep it as 12. And now if we want to isolate a, we want to undo multiplying by 4 on both sides. So a equals 3. But remember, the question didn't ask what is the vertical stretch or the a term. It asks what is the equation of the parabola or the quadratic. So one less substitution to make here, we can get an equation of y equals the a term now will be replaced by 3. So y equals 3 times x squared. And there it is. That's the equation of this parabola. Notice how this one was y equals 1x squared. This one is y equals 3x squared. All right. So that type of thinking is going to be applied to the rest of the video. It's just going to get a little more advanced. Let's do 2 more examples of this so you can get comfortable before we move on to something more complex. I'll even challenge you to try them yourself. Let's check. The main idea identified is both of these go through the, they both have a vertex that goes through the origin. So we know it has to be some form of y equals ax squared. Although that's not a form of quadratics that you should memorize in your head. It's just a specific example for now. That happens to be convenient, but it's not something you should memorize. But for this, we know we have to use y equals ax squared. And then we need to identify, all right, which one is x and which one is y? Is x -3 or is x 15? X is -3, y is 15. Now let's make some substitutions. Wherever we see a y, we're going to replace that with the positive 15. And then we have equal to a, which is the vertical stretch that we're trying to solve for. And this will say -3. Don't forget, this was -3 squared. And the nice thing is that when you square a negative, we get a positive. So the left side remains the same as 15 equals -3 squared is 9. So 9 times a. We want to undo multiplying by 9 by dividing both sides, so the equation by 9. And then we can simplify 15 over 9. What goes into both 15 and 9? That's the common factor. So we can simplify this. Into 15 is, well, both of them have a share factor of 3, so it's 5 over 3. 3 times 5 is 15, and 3 times 3 is 9. I hope you don't have a problem with that. That's not the main point for this lesson. But that means that now we have to make a substitution here, which gives us a equation of 5 over 3 in simplified form times x squared. This has a vertical stretch of 5/3 because this is greater than 1. That's pretty cool that we can find the equation of a parabola through almost any 2 points. That's not always the case, but in these special cases, we can't. Last example, let's check your work if you tried it ahead. Remember that this is 0, 0, but that's not our main point. This is the most important one down here. So again, we start with some form of y equals ax squared, where finding the value of a is the most daunting task of this problem. What is the x value? Is it 6 or -12? It is 6. What's the y value? It is -12. Let's make the substitution. So -12 is going to be equal to some vertical stretch times 6 squared, because x was 6. Let's do a little bit of algebra here, simplifying, or arithmetic, however you want to think about it. We know that -12 is 36a. Check your own work. So a is -12 over 36. And for the users that are really fast, is, see if you did it faster than me, is -1 over 3. But it didn't ask for the scale factor. We want to know the equation of the parabola. So that's going to give us an equation of y equals to negative 1/3 x squared. And ask yourself, does that make sense that the a factor is a negative? Is it curving upwards or downwards? And does that make sense with what we got? Because it's curving downwards, this a term better be a negative, and it is. And for the previous examples, they were all curving upwards, so all the a terms were a positive, like +1, like +3, or like +5/3. That's another strong connection to make here. All right, if you're having a little bit of trouble, you should not move on from here, because these questions are really seen. The next two are the most common, number 3 and 4. But if you understand the first few examples, then this is going to be something that makes a lot of sense, and you don't have to remember a lot of formulas or a lot of steps to replicate. It's just common sense. But try and analyze. Take like 10 seconds to see, what do these two have in common? These two quadratics, these two parabolas, what is their difference? The things that are different, okay, that they have in difference, and what do they have in common? All right, so let's talk about that. And hopefully you say that it says think x-intercept form. And why would I say that if I wouldn't give you the hint? What was given to you? The x-intercepts. And that's one thing that I wanted you to think about. The x-intercepts were given to us. So the equation, if we're going to write it, it better be in some form of, let's use this chalk color right now. Y equals some vertical stretch times something times something. Same thing for this one. Y equals, and this one has to be y equals something. I mean, a times something, some vertical stretch or compression times something times something. We'll come back to that. We got to focus on this right now. Okay. So what was given to us? The x-intercept. So what factor gives us an x-intercept of -2? Is it x minus 2 or x plus 2? We want to get a 0. Therefore, it is x plus 2. What factor gives us an x-intercept of 4? Is it x plus 4 or x minus 4? That's right, it's got to be at x minus 4. But notice how we don't know this value yet. And I asked my students, did we utilize this point yet for our equation? Yes. Did we use this point for our equation? Yes, it was another x-intercept. Which point haven't we used? Is this 0, -8? So let's assign this some values. Which one is x? Which one is y? That one's x. Well, you're doing some thinking because I'm messing up here, and that one's y. And now we know we can make some substitutions or replacement. When we see a y, we can replace that with a -8 down here. Notice how y is now -8. We're trying to solve for the a factor, the vertical stretch. But the nice thing is that we have 0. X is 0. 0 plus 2 is 2. And 0 minus 4 is -4. That's what's going on right there. And now we know that -8 on the left side doesn't change, but 2 times -4 is -8. So -8a. And that means that a equals 1. Which this is a slow way of doing it. At some point I'm trying to show you a faster or more efficient way. But for right now, this is the best way to understand them. There's no need for shortcuts at the beginning of your learning. And while I'm messing up, that gives you more opportunities for you to synthesize or think about what we're doing. All right, cool. And then I can make that replacement. That's not answering the question quite yet. We know that the equation now has to be y equals 1 times x plus 2 times x minus 4. And the nice thing is that when a equals 1, we haven't written that ever. So I'm just gonna remove that. It's just that. And that's awesome. And the reason why I don't mind going through all this work is because I might do it again here. But is this parabola the same as this parabola? And hopefully you can see no way, because the y-intercept changes, but the x-intercepts are the same. So let's see how we can show that algebraically with math or algebra. The nice thing is that because we have -2 here, it's still an x plus 2 term. like in the previous one right here. And because that didn't change, it's still going to be at x minus 4. That's going to still give you a 0. So the main thing that probably will change is the a factor. And we're going to label them again. What's x? A 0 or a 24? X is 0 and y is negative 24. So when we make those substitutions, we get a negative 24 on the left side. It's equal to the a term, which we're trying to solve for, times something times something. And the nice thing is, because we're plugging in a 0, we get a 2. And because we're plugging in a 0 here, we get a negative 4. That's super easy mental math. However you want to simplify, we get a negative 24 is equal to negative 8 times a, or negative 8a, which means that a term, the vertical stretch, is 3. And that should make sense because our parabola is curving upwards. And hopefully you see that. How many times is this y-intercept larger than that one? Let's see if you can make a connection. How many times larger? It is 3 times larger, which should make a lot of sense. And hopefully you can skip this step in the future. But it's all right. This is very mathematical, which means that the equation of this quadratic is y equals 3 times x plus 2 times x minus 4, which is 3 times larger than this version of the parabola. Look, notice how this is a 1. This one's 3 times larger. But anyway, that's not the point of writing the 1. We don't like writing the 1. But that's awesome. Look at those connections. And that was which form? X-intercept form. That one shows up a lot for these type of problems. And then another form that we learned, the very first one is, oh, there's 2 more. See if you want to try them yourself. I'm going to try and speed up on these because it's the same idea. All right. So we're going to say that this has to be y equals a times something for the x-intercept of negative 10. Pause if you need to, but here it is. It better be a x plus 10. For the x-intercept of 3, the factor better be x minus 3. And then we know that, I'm going to tell you how I think about it in my head without showing all the work. Oh, never mind. These are a little bit more advanced, and I did that on purpose. Forget that. We'll show that later. Okay. So then we know that we already used this one. We already used that one. We're yet to remain using the x and the y. X is 0. Oh. And then y is negative 6. So then we have that negative 6 is equal to this vertical stretch, or a term. And remember, the nice thing is that 0 plus 10. When x is 0, we have 0 plus 10, which is just 10. When x is 0, we have 0 minus 3, which is negative 3. So therefore, we get, on the left side, nothing changes. We get a negative 6 equals a times 10 times negative 3. It's negative 30. Which means that now we have a equals negative 6 over negative 30 is the same as 6 over 30. And that simplifies to 1 over 5. At some point, my goal is to help you see this in your head mentally, mentally without doing any of this work. If you can already do that without me telling you specifically how to do that, you're doing great. All right. But it doesn't hurt to do it this way. It's good practice for future courses. Right here, again, we have something times something because the x-intercepts are given. But hopefully you realize, because this is curving downwards, that our a term should be a negative. Here we got a positive. We were expecting that. It was curving up. If we don't get a negative value for a, we did something wrong. So still, let's set it up as y equals a times something times something. What's the factor for x-intercept of negative 6? It was x plus 6. What's the factor for x-intercept of 2? It was x minus 2. And we can go through our checklist. We already used both of these points. the last one we yet to use our y-intercept, which has an x value of 0 and a y value of 24. So let's make some substitutions. When we see a y, we're going to replace that with a 24. On the right side, we get a, the stretch factor which we want. And the beautiful thing is that when we plug in a 0, we have 0 plus 6. What's 0 plus 6? It is 6. And what's 0 minus 2? It's negative 2. Now that's going to give us a 24 equals a times, oops, I don't want to write a times some constant. Let's do this. What's 6 times negative 2? Negative 12a. A times negative 12 is the same as negative 12 times a. So therefore we know that dividing both sides by negative 12 gives us a value of negative 2. And look at that. That's exactly what we expected because it was curving downwards. That should make a lot of sense. Putting this back into the original form of x-intercepts, we get that y equals, I'll write the answer in green, we get that y equal, let's redo that. We get that y equals negative 2 times x plus 6 times x minus 2. And that's done. Simple as that. But I hope that at some point you visualize what's going on so that you can skip some steps and go straight from this picture to this equation. It's not that hard. You can do it in your head if you know what's going on down here, which is why I wrote it so you can see it a few times. All right, so that's two forms, the main form, and then we have the other form that's going to show up constantly, which gives us 3 examples. I'm going to try going a little bit faster, but the idea is the same. And I give you a big hint. What is given in this form of quadratic equations? Not the x-intercepts, not the y-intercept, but the vertex. The vertex is given, so we should think vertex form. This has to be some form of y equals something squared. When this is 0, the y value of the vertex is negative 5. If you're confused about this so far, then go revisit vertex form or previous videos because you have no business continuing and you're going to be more confused. Try to understand vertex form before you proceed. Okay. And remember that we get our lowest or highest y value when this part is equal to 0. How do we bring this 2 back to 0 when x is negative 2? But now we have the problem that, there's an a factor involved always. Oh, man. Now we just can't assume that a equals 1. So we're not going to assume that. Let's show if it is 1 or if it's 12 or if whatever it is. Let's show what's going to be. And I asked my students, which point have we used already? It is the vertex. This one's done. So what information haven't we used yet? We have this point. What is the x value and what's the y value? X equals 4 and y equals 7. So let's make those substitutions. When we see a y, we can replace that with the 7. And now we can say that 7 is equal to the vertical stretch factor a times, now it's not a 0. Be very careful. Now it's a 4. So I'll show that 4 minus 2. You have to be extremely careful with this one. Squared and then minus 5. That doesn't change. But we replace the x and the y as shown here. And then we get 7 equals a times, what's 4 minus 2? It is 2 squared. And then minus 5. So hopefully you realize that this is 2. 7 equals 2 squared is 4. So 4a minus 5. We're going to bring that right here because we're running out of space. Let's separate that from the last problem down there. All right. And then we can say that, I'll just rewrite it. 7 equals 4a minus 5. How do we undo this subtracting 5? Let's add it to both sides. 7 plus 5 is 12. And 4a remains on the right side. So we know that a equals 3. And that's what I'm saying. That's a lot of work. But because we were able to do some of these problems in our head before, that doesn't mean you can do all of them or in your head. This one would not be that easily. You wouldn't be able to do it in your head that easily. So that's why learning those previous techniques are convenient. And then we can write the equation. I'm going to do that in green. We know that the equation of this quadratic, it is a y equal to 3 times x minus 2 squared minus 5. And done. That's the equation of this parabola right here. That's amazing, right? That we can figure that out just by giving 2 points. But it had to be perfectly chosen points like the vertex or the x-intercepts. Like this next one, we could only do it because the vertex is given in another point. So again, we're going to do the same type setup. See if you want to pause it and try yourself. But we should start with y equals a times something squared. When the vertex gives us a value of 0, what's the y value? When the x gives us a 0, what's the y value? It is positive 6. And remember, what makes it 0? Is it x minus 2 or is it x plus 2? It is x plus 2 because 2 minus 2 is 0. And now we know that all we need to replace now is an x and a y value to solve for a. So we already used this point. We're yet to use x equals 5. And we're yet to use y equals negative 4. So negative 4 is going to be equal to the vertical stretch a times something squared plus 6. And remember that the x value now was, be careful, not 0. Now it's 5 plus 2. All right, this simplifies to a negative 4 equal to a times 7 squared plus 6. So therefore we know that negative 4, whoops, let's redo that. We want to undo this plus 6. How do we undo adding 6? By subtracting 6. So be very careful, check your own work. Negative 4 minus 6 is negative 10. And then we know that, well, let's write it as a times 7 squared, I guess. That part's still the same. So we know that negative 10, although I didn't write all this work, it's just for you. 49a. So therefore, this should be a equal to negative 10 over 49. And that's why I chose this problem, so you can't just guess it in your head and without showing any work. Sometimes you got to go through all this process of the algebra. But again, this is incomplete. So we're going to write the equation, since we figured out the a term, as y equals, I forgot what it was, negative 10 over 49. Look at that vertical compression. That's not a stretch, that's a vertical compression. Times something squared plus 6. And that something is x plus 2. I'm going to rewrite this somewhere because it doesn't look good right there. Let's move this right here. There we go. That should box my answer. All right, in this last one, if you already understand these ideas, you're probably good to go. If you want to stick around, you're probably a math nerd like me. So let's go over them. What do you notice about this one? What form should we use? That's why I like this problem. There's not one correct answer. You can go through 2 answers, to be honest. I don't know if I'm going to do them both because I think this video is already too long. But what would you use? If you immediately notice x-intercepts and say I could use factor form, then you're right on track. That's perfect. That's amazing. But if you didn't notice that and instead notice, oh, we were given the vertex, I can use vertex form, then you're also on the right track. But the best students will notice, oh, I can use factor form because of the x-intercepts, but I could also use vertex form. If you notice both of those two, you're Even if you didn't solve it, you're ahead of the game. So I'm thinking of doing it both ways. I think I am because I'm a math nerd. If you don't want to stick around, that's your problem. So let's do it by factor form, because that's my favorite form, to be honest. Yeah, and I'm going to try to speed up anyway. That means that we have y equals a times something. And this one I couldn't do in my head. That's the beautiful part about it, because the y-intercept's not given. The other ones I was able to. Y equals a times something. We have x plus 8. I'm not going to explain that to you, because if you need me to do that, you're in trouble. And then x minus 2. Check. We already used those two. Now we got to use x and y. Y is 10. X is negative 3. So y equals, oops, sorry, let's redo that. Now y equals, we said 10. 10 equals a times, and we said that x was negative 3. So negative 3 plus 8. And then negative 3 minus 2. So we know that 10 equals a times negative 3 plus 8 is 5. Negative 3 minus 2 is negative 5. So 10 equals negative 25a. And that means that a equals 10 over negative 25. Or 2, negative 2 over 5. You check your own work there. But that's it. Oh, and what's nice is that we can say, all right, and you'll see, hopefully we get the same a factor next. We can say that y equals negative 2 over 5 times x plus 8 times x minus 2. If we don't get an a term of negative 2 over 5 next, then I did something wrong and we got to check our work. Cool, that's factor form. And that's what I'm saying. If you notice both, then oh man, you're doing really good. What if we use vertex form instead? How would you set that up? See if you can do it ahead of me. Vertex form, you got to pay attention to the vertex right here. And it's going to be y equals, for vertex, we need y equals a times something squared. The y value is 10. So positive 10. And how do we get a 0 inside? Not by x minus 3, but rather x plus 3. And done. We already used that one. We already used that point. But now I'm going to ask myself, which point haven't I used? And the good thing is you can use this one or you can use that one. Negative 8 is larger, so I'm going to go with this one. So I make smaller computations, x and y. All right. So then we can say that 0, y is 0. A is still what we're looking for. Remember, 2 is x. So 2 plus 3 squared plus 10. So then we get that 0 equals, I'm going to write it like this. Yeah, a times 5 squared plus 10. So that we get negative 10 equals 25a. And to solve for a, we want to do multiplying by 25. So we get that a equals negative 10 over 25. And notice that that reduces again to negative 2 over 5. And done. You could have done it either with vertex form or x-intercept form. And either way, oh, but look, even though we don't write them in the same way, but we get the same stretch factor, which is how you know they're the same. But notice how this is beautiful. Now we can write this as negative 2 over 5 times something squared. That something was what? X plus 3 plus 10. And we would have never known otherwise that these two are equal to each other, which is amazing. That's really cool to see. These two are identical even though they don't look like it. Right? That's how beautiful math is sometimes. Look at that. I don't want to see that they're the same, but they are. You can go on Decimals or a graphing calculator to verify if you don't believe. But you better believe that. All right, y'all. This is the end of this video. This was kind of fun for me. If it was too long for you, I'm sorry, but I love math. And if you don't, then go find another tutor or another channel to look at. All right, so have a good rest of your day, and thanks for tuning in. We got more cool things coming up next.